Have you ever wondered how something as smooth as flowing water, keeping the or as gentle as the air around us, could emerge from complete chaos? Because at the microscopic level, nothing is smooth. Nothing is calm. There are around 10 particles constantly flying around, colliding with one another billions of times every second. Each particle follows only one rule: the laws of motion. No particle knows where the whole system is going. Yet somehow, all of them together create flowing rivers, ocean waves, wind, and even the air that keeps airplanes in the sky. So here's the question. How does complete microscopic chaos become perfect macroscopic order? For more than 150 years, this question has challenged some of the greatest minds in mathematics and physics. And in 2026, Chinese mathematician Yu Deng, one of the winners of the Fields Medal, made one of the biggest breakthroughs yet. More than 150 years ago, Austrian physicist Ludwig Boltzmann introduced what is now called the Boltzmann Equation. It became one of the most important equations in modern physics. Scientists use it to describe how enormous numbers of tiny particles behave collectively. It is used in aerospace, plasma physics, vacuum technology, and semiconductor research. The equation works remarkably well. There's just one problem. Physicists believed it was correct. Engineers trusted it. But mathematicians wanted something more. They wanted a proof. Not an experiment. Not intuition. Not assumptions. A proof. Imagine trying to predict a hurricane. Most of us would look at weather maps, satellite images, or computer simulations. Mathematicians wanted something much harder. Imagine following every tiny molecule of air and every drop of water, one by one, and proving, using only Newton's laws, that together they must eventually produce a hurricane. That sounds impossible. And that's exactly why this problem remained unsolved for generations. Over the past several decades, many brilliant mathematicians made important progress. But most of them could only prove that the Boltzmann equation worked for a very short period of time. What happened after that? Could the mathematics remain stable forever? Or would everything eventually fall apart? No one knew. Yu Deng approached the problem differently. He developed powerful new mathematical techniques to control the incredibly complicated interactions among an enormous number of particles. His breakthrough showed that, for an important class of solutions, the Boltzmann equation remains mathematically well behaved over long periods of time, not just for a brief moment. This was a major milestone in kinetic theory. It also marked one of the most significant advances toward Hilbert's Sixth Problem, one of the most famous challenges in mathematics. To be clear, Yu Deng did not solve the entire Sixth Problem, but he solved one of its most fundamental pieces. And that is why mathematicians around the world consider this work extraordinary. Now you might be thinking, that's fascinating. But why should I care? Here's why. History has taught us something remarkable. Many of today's most important technologies began as abstract mathematics. Einstein's theory of relativity later became essential for GPS. Number theory, once considered completely useless, now protects almost every secure transaction on the internet. Pure mathematics often becomes the engineering of tomorrow. Yu Deng's work strengthens the mathematical foundations behind models used in aerospace, plasma physics, semiconductor research, and many other scientific fields. No one knows exactly which future technologies will grow from today's mathematics, but history suggests they will. The greatest mathematical discoveries rarely change the world overnight. Instead, they quietly strengthen the foundations of science, until one day the future is built upon them. Yu Deng didn't invent a new machine. He didn't create a new material. What he did was something even more fundamental. He helped us better understand how countless microscopic collisions become the orderly world we experience every day. And that's why, in 2026, he received the highest honor in mathematics, the Fields Medal. If you were living 100 years ago, would you have believed that a single mathematics paper could one day reshape the world? Could Yu Deng's work be the first step toward the next scientific revolution? Share your thoughts in the comments.